Thanks for the introduction, Kim. I can't promise I'll be as articulate as the last presentation. I might ramble a little bit about my experience, but I wanted to talk a little bit about the last 18 months of mine. I've been able to have a few successes, definitely a lot of failure, but I want to be able to leave you at the end of this presentation, not necessarily to quit your day jobs and start your own clean tech construction company, but hopefully to think about how you can apply the resources and skills in your local area to develop solutions for low energy building. Yeah, before we get into that, I was going to start with a bit of a story time. And essentially, back in the winter of 2022, I was in an online business class at the University of Calgary, thanks to COVID. I think I maybe got to step foot in the building like 3 times in the 2 years that I went there, but lots of hours clocked on Zoom. But I had one class that was oriented around how to identify and solve problems through the application of entrepreneurial thinking principles. My classmates and I were tasked with finding a problem, developing a solution, and figuring out whether that solution could be more valuable than it cost to implement. So we found out pretty quickly that it's easy to identify a problem. They're literally everywhere. We also found that most of the time it's easy to find a solution. Proving that solution was more valuable than it costs, however, was a very different ballgame. Prior to this class, I'd done a little bit of work calculating the climate impacts of some of my local small businesses. This means I looked at the direct and indirect greenhouse gas emissions of some of their products, like calculating the impact of a bar of soap and a pair of shoes, things like that. And it was in this I learned what operational and embodied carbon was in the construction industry. So this is the problem that I wanted to solve with entrepreneurial thinking. And so identifying this issue is fairly simple. Pretty much all the governments that I'm aware of, architects, and a lot of building owners now are becoming increasingly vocal about how the climate could be affected by the carbon-intensive materials and failing to design buildings with adequate energy efficiency. And this is something that most of you would be pretty familiar with at this point. And you're aware of some of the solutions. Use less steel, less concrete, try to use insulation with lower levels of embodied carbon like cellulose or wood fiber. I'm sure what you have found, though, is that it's not so simple to actually prove whether these low energy building solutions actually generate more value than they cost to implement. But with some youthful optimism and a lot of naivety, I set out to solve this problem with a great deal of confidence. One of my biggest takeaways from this entrepreneurial thinking class was the concept of build, measure, learn. This means if you have an idea, get it out in the world as fast as you can so you can get feedback. Now this could be a digital prototype, really simple testing, or build a physical mock-up. Determine some key metrics, what would deem it successful, and then take that feedback and use that to iterate on your solution. And in other words, for me, if I wanted to actually develop a low energy building solution, I would need to go build some stuff. So the first thing that I built was a shed. And this seemed like a pretty reasonable place to start, but it was actually pretty hard to do. I don't have a background in the construction industry. I'm not very good with computers or public speaking, and I certainly didn't have much money for trial and error. But despite this, I spent the summer of 2022 modeling each component of this shed in construction software, building prefabricated panels that were insulated with chop straw. So it's a pretty good insulator, and it's a really good carbon sink. And then standing it all up with a crane. While there are certainly lots of challenges with this project, I'm pretty happy to say that over a year later, it has not fallen over. My dad actually uses it as a woodworking shop, and I'm pretty sure he heats it with a candle. And so that summer was a great crash course in working with a low energy material, understanding the construction process a little bit more, and seeing how prefabrication could be a part of that equation. So I decided to double click on that last piece, prefabrication. It was clear that while working with chop straw, it would be very difficult to insulate buildings on site like you would with a fiberglass bat or rigid EPS board. Instead, it made much more sense for my company to source the straw directly from local farmers, process it or chop it, store it in a tent, and then install it into a wall or roof or floor panel in a controlled environment opposed to on-site. You then load these panels onto a truck, ship it to site, and then stand it up with a crane. There was a big gap in my company's prefabrication capability, so I decided we need to go build some more stuff. I spent last winter building wall panels for multifamily buildings in the Edmonton area. And while we weren't working with chop straw insulation or high performance enclosures and advanced structural techniques, I got the opportunity to learn a lot. And I did have the joy of going to site on minus 30 days to fix framing errors that we'd screwed up in the shop. But I got to learn what a point load was. I got to see how many 2x6 studs make up a lift of lumber. And just a lot of skills that I didn't necessarily think would be that important for prefabrication, but have turned out to be incredibly, incredibly important, whether it's building information modeling, understanding logistics, and spending a lot of time on the shop floor and learning about small-scale manufacturing. But it's starting last spring, so in 2023, my team and I, we decided to take a step away from these conventional uninsulated panels and put our full focus on chop straw insulated assemblies. And so this decision was not an obvious one. It came with a lot of risks. The straw shed that we built a year ago was really just an extension of a student project. Now we've got bills to pay and we have customers to work with. So we definitely had lots of positive feedback from professionals in the green building community, but in order to really prove if this could be viable, we had to get it out there and we had to go build some more stuff. And so that's what I did this last summer. We built ourselves a straw insulated shop that we now work out of, along with an office that I spend quite a bit of time in. We built someone in Rocky View County a straw greenhouse. We built someone in Calgary a straw insulated garage suite. And then most recently, we just built another shop in Leduc County. That was really fun to work on. And so I've definitely got a lot of stories about these projects, too many to fit into a 20-minute presentation. So if you ever want to grab coffee with me sometime, I'll talk your ear off about it. But I hope that, I know for myself, I've definitely had the future approach for my next projects influenced by these past experiences, but I'm hoping that you can also learn a bit from them as well, and see, despite even some of the projects that we're all going to take on, they're not all going to be super successful. Like I've lost money, I've had to lay people off when we had a gap in production, and I've definitely struggled to personally earn a paycheck. But I would look at all this as a huge success in that we've been able to actually go and improve a lot of stuff that was not obvious was possible before actually going and doing it. So the next year for me, I'm a lot more optimistic about, but we still have some pretty significant technical and business hurdles to overcome. What we can be really confident about, though, is the track record of implementing a build, measure, learn strategy. So this is why I want you to start approaching your own problems with this formula. I think most people here will agree that the construction industry today has quite a few challenges. I don't think it's a great thing to have people living with poor air quality, high utility bills, and pretty significant contribution to not just climate change, but also local environmental concerns as well. But what I can see is that we do need to be conscious of not just acknowledging these issues. Like there's a lot of LinkedIn posts who are about the latest government policy or construction practice or pledge for better buildings. But when people go, it's rare you're going to find someone who's actually working to make this better instead of just saying they're going to make it better, which is why I'm really happy to be in this room, because pretty much everybody here is spending a lot of energy actually trying to make things better. But it's definitely not obvious that this is going to be without risk. Like we have to be able to tolerate some risk, and we have to be able to tolerate the fact that we are going to fail when we are putting forward these imperfect solutions. But if your organization survives the failure and you get to take that feedback to further improve your solution, you get the privilege to set it out in the world again and repeat that process. And then everything that survives that process is going to be really strong. And I really do think that we're going to be able to outcompete the current construction practices that are contributing to quite a few problems right now. And so you might be wondering how local ties into low energy building solutions. And on the surface, local solutions contribute to the environmental sustainability of a particular building practice. Less energy is required to transport raw materials or even finished products to the construction site. I often joke that my supply chain is getting too long because this year we had to transport our straw bales 3 kilometers instead of 2 kilometers like last year. But working with materials like straw, they enable this hyperlocal approach, which I think is really cool. But I'm trying to put forward a local solution. I think we can extend it a little bit further. And so what I really mean by local solution is not being afraid to look in your own backyard, to find the talent, know-how, and capabilities required to implement low energy building solutions. In this room, we have some of the most knowledgeable and experienced professionals in all of Western Canada to address some big problems that we're facing. On the material side of the equation, like Alberta, we've got some really good plywood here. Our cold climate makes some really strong dimensional lumber, and we've got a lot of straw kicking around as well. But I think if working locally, it shifts the way that we can approach failure and risk. Like you don't have to be a huge company to try out new solutions. Like if you are going to have a centralized production facility to serve all of North America, and you're wrong just a little bit, there goes millions of dollars. But if you do what I've been kind of doing, where you start out small, you get to start on that micro or hyper local scale. You get feedback almost immediately when things aren't going the right way. And that failure is easy to recover from most of the time. I've had to go back to the drawing board on countless problems in the last year, whether it's a minor construction detail or a major process in our shop. If my team and I get it wrong, which again is often, it can quickly be improved, and we can try it again and get better at it. when I started this presentation, I told you that my hope was that you'd walk away thinking about how to apply the resources and skills in your local area to develop solutions for low energy buildings. So how can you do that? Well, we can start with identifying the problem. And for me, I was probably a little too broad, emissions in the built environment. And I was quickly forced to break that into pieces, like what's a good carbon storing insulation material to work with? And then that progresses to more actionable items, such as which dairy farmer do I need to call to find straw at a particular moisture content. But whether you install solar panels or perform energy audits or even design low energy buildings, I can assure you that finding a problem to solve won't be an issue. Finding a solution for it might be a little bit trickier, but I believe in all of you. I think you've got lots of ideas on how to solve a lot of problems. But where you're going to spend most of your time is finding out whether the juice is really worth the squeeze. Like, is this solution actually solving the problem, and is it sustainable to really keep doing this? And to figure that out, you're going to need to build some stuff. And try to do it quickly, get feedback as soon as you can, and determine what needs to be done to improve your next attempt. You'll probably find that your original solution needs a lot of improvement. You'll need to adapt it. And honestly, what you actually have at the end of this process will look a lot different than what you started with. But I think you're going to create something that's really strong. Now, you could be starting a company to compete with me in the low energy materials manufacturing and prefabricated construction industry. But you could probably start with just organizing your computer files in a little more efficient way. The size and scale of your risk-taking, exposure to failure, that's all going to be different. But it's the same process. Just try to build it, get it out there, learn from it, and then improve it. But yeah, thank you all for listening to this. You guys are certainly a busy group of people, so this event is really special. So thank you so much.